morning, friends. We discussed about the equation of the VIMS, different equation of the VIMS. One is the under root of 3p upon rho. Second is for 1 mole of a gas. The equation of the VIMS is equal to under root of 3 kBT upon small m. M is the mass of molecule of a gas. And we derive the third equation of VIMS for 1 mole of a gas. So VIMS is equal to under root of 3 RT upon M0. M0 is the mass of 1 mole of gas. Right? Okay. After the discussion of the equation of the VIMS, our next topic is the law of equipartition of energy. Law of equipartition of energy. That means the energy is equally distributed or equally divided according to the separate independent motion of a particle. What is the meaning of the independent motion of the particle? When we derive the equation of the pressure, at that time the gas is filled in a container. It has the possibility of the linear motion in 3 directions according to the Cartesian coordinate system x, y and z. What is the energy of this particle along each direction associated with the independent motion along the x-axis, y-axis and z-axis? So here we are going to discuss this topic. Here the question is that write and explain law of equipartition of energy. This law is suggested by the Maxwell. Now the statement of the law of equipartition is that in equilibrium the total energy is equally distributed in all possible energy modes with each mode having an average energy equal to 1 by 2 kBT. 1 by 2 kBT. It appears that in equilibrium, if the gas filled in a container is in equilibrium, the total energy of a gas is equally distributed in all possible energy modes. That means the all possible independent motion of a molecule. And in each mode, that means in each independent motion, the energy, average energy equal to the half kBT. Right? So as the particle performs the linear or the translational motion, it has the 3 independent motion along the x, y or z direction. And due to that reason, average kinetic energy of molecule of a gas is 3 by 2 kBT. Already we have this equation, half m average square is equal to 3 by 2 kBT. This 3 represents the 3 different independent motion of a molecule. Therefore, the average kinetic energy, the average energy associated with each mode of the motion, or each mode of energy is half kBT. Half kBT. So again, we repeat the statement of the law of equipartition. In equilibrium, the total energy is equally distributed in all possible energy modes or the all possible independent motion with each motion having an average energy equal to half kBT. Each mode of energy has an average energy equal to the half kBT. Right? Okay. Now here we consider only the translational or the linear motion of molecule of a gas. Therefore, the total average energy is equal to, we know that, there is the half mv square. There is the total energy of a molecule of a gas. Average T, ET, is equal to average half mv square. But V has the 3 components along the x, y, z direction. Therefore, we can write the total average energy is equal to average half Vx square plus average half m Vy square plus average half m Vz square. That is the equation number 1. Now consider 1 mole monoatomic gas is at temperature T and is in thermal equilibrium. Here we consider the 1 mole of gas at temperature T and also in thermal equilibrium. Therefore, average kinetic energy of the monoatomic gas is total average energy T is equal to ET is equal to half m average V square. But we have this equation, the average kinetic energy is equal to 3 by 2 kBT. 3 by 2 kBT. Now listen, from equation 2 and 1, average total energy is equal to average half m Vx square plus average half m Vy square plus average half m Vz square. That means from equation 2 and 3, left hand side are same. Therefore, we can add average half m V square is equal to average half m Vx square plus average half m Vy square plus average half m Vz square. But here in thermal equilibrium, the particle or the molecule of the gas perform the random motion and the possibility of the motion in all directions are equal. Therefore, average Vx square is equal to average Vy square is equal to average Vz square. Therefore, we can add Vx, Vy, Vz are same. Therefore, half m average V square from equation 3 is equal to 3 by 2 kBT. But is equal to what? 3 times half m average Vx square. 3 cancel. Therefore, average half m Vx square is equal to half kBT. That represents the independent motion along the x-axis. Thus, the energy associated with each independent motion is half kBT. The similar way, half m Vy square is also half kBT and half m Vz square is also half kBT. So according to this equation, half kBT plus half kBT plus half kBT, so that gives the 3 by 2 kBT. Thus, the energy associated with each degree of freedom. What is the degree of freedom? We discuss in next lecture. But here, the degrees of freedom, that means the number of the possible independent motion possessed by the molecule of a gas, that is known as the degree of freedom. Again, the degree of freedom, that means the possible independent motion possessed by the molecule of a gas, that is known as the degree of freedom. Here we consider the monoatomic gas, it performs only the linear motion. During its linear motion, here the 3 independent motions are possible. Right? And therefore, the energy associated with its degree of freedom for the independent motion is half kBT. And that is the constant. Because the Kb is Boltzmann constant, at given temperature T is constant, and half is also constant. This represents the Maxwell's law of equipartition of energy. Clear? Again, we repeat this law because there is a quite complicated here in equation. Nothing but there is a average energy is equal to half m v square. Here we have to substitute the component of velocity. Therefore, half m vx square plus half m vy square plus half m vz square. And using the concept, all the molecules perform the random motion, and in thermal equilibrium, the velocity in all directions are equal. Therefore, this vx square is equal to vy square plus vz square. Therefore, in this equation, there is 3 times of the half m vx square. And already we derive this equation. Average translational kinetic energy is equal to 3 by 2 kBT. Compare these two equations, we obtain it. Now, the statement of the law of equipartition. In equilibrium, that is the most important in equilibrium word. The total energy is equally distributed in all possible energy modes, with each mode having an average energy equal to half kBT. Again, in equilibrium, the total energy is equally distributed in all possible energy modes, with each mode having an average energy equal to half kBT. That is the statement of law of equipartition of energy. Now we know that the total average energy averagity is equal to in all direction. Here we consider only the linear motion, therefore the three independent motion or the three mode of motion, half m vx square base plus average half m vy square plus average half m vz square. Now consider one mole gas, right, is at temperature T and also in thermal equilibrium. Therefore, average kinetic energy of the monoatomic gas is average total energy is equal to average half m v square. And also we know that average half m v square is equal to 3/2 kBd from equation 2 and 1. So half m average v square is equal to average total energy, and average total energy is equal to this. Left hand side of both equations are same. Therefore, comparing equation 1 and 2, we obtain average half m v square is equal to average half m vx square plus average half m vy square plus average half m vz square. But we know that average vx square is equal to average vy square is equal to average vz square. Right? Now from equation 3 this 3/2 kBd or the half m average v square is equal to 3/2 kBd. And from this equation half m v square is equal to all these three are same, vx square, vy square, vz square. Therefore 3 times half m vx square. So 3 cancel. Therefore average half m vx square is equal to half kBd. This equation 4 represents that the average energy in this mode of motion or the independent motion is half kBd. So the same equation we can also obtain for the half m vy square is also half kBd. Average half m vz square is also half kBd. Thus, the energy associated with each independent motion is half kBd. Or in other words, the energy associated with each degree of freedom is also half kBd, and which is constant. What is the degree of freedom? The possible independent motion possessed by the molecule of a gas is known as degree of freedom. Here we consider the monoatomic gas. So this monoatomic gas possesses only the linear motion. Therefore, it has only 3 independent motion. 3 independent motion. Therefore, degrees of freedom for the monoatomic gas is 3. And the energy associated with each degree of freedom is half kBd. So this represents the Maxwell's law of equipartition of energy. Clear this? Now, after that, we are considering the one numerical of exercise, that is the 13.9, to find out the temperature. At that temperature, the VIMS of argon gas is equal to the VIMS of helium gas kept at minus 20 degrees centigrade. So that is the most important numerical. Frequently this type of the numerical or the objective question is asked in competitive exam. Now the question is that there is the numerical of exercise 13.9. That is also most important. Now at what temperature VIMS of an atom of argon gas equal to the IMS of helium gas at minus 20 degrees centigrade. Atomic mass of the argon is 39.9 atomic mass unit and helium is 4 atomic mass unit. For argon, we consider the one notation. Here the temperature T1 we have to find out. Atomic mass M1 is given 39.9 atomic mass unit. For helium temperature T2 is given minus 20 degrees centigrade. Convert into the Kelvin. Therefore, minus 20 plus 273. That means the 253 Kelvin. That is the temperature of helium in Kelvin. Right? Okay. Now we have to find out here the atomic mass M2 of the helium is given 4.04 atomic mass unit. Now we have to find out the temperature of the argon. Here the atomic mass are given, therefore we are using the equation of VIMS for 1 mole. Atomic mass given, that means the molar mass given, therefore we are using the equation of the 1 mole of gas, VIMS of 1 mole of gas. Therefore, VIMS of 1 mole gas is VIMS is equal to under root of 3RT upon capital M. Now, for argon, there is the VIMS 1 is equal to under root of 3RT 1 upon M1. And for helium, VIMS 2 is equal to under root of 3RT2 upon M2. But here, VIMS of both gases are same. VIMS. Therefore, substitute here under root of 3RT1 upon M1 is equal to under root of 3RT2 upon M2. So 3 are cancelled. Square root is also cancelled. Therefore, T1 upon M1 is equal to T2 upon M2. T2 upon M2. We require the value of T1. Therefore, T1 is equal to T2 into M1 upon M2. M1 upon M2. Now substitute the value of T2, 253. M1 is 39.9 upon 4. Atomic mass unit are cancelled. Therefore, we obtain 2.524 into 10 raised to 3 Kelvin. That means 2524 Kelvin. That is the value of T1. For this temperature of the argon, the VIMS of an atom of argon gas is same as the VIMS of the atom of the helium gas kept at minus 20 degrees centigrade. Very easy numerical. Now listen again. At what temperature the VIMS of an atom of argon gas equal to the IMS of helium gas kept at minus 20 degrees centigrade. Atomic mass of the argon 39.9 atomic mass unit, and for helium 4 atomic mass unit. For argon, we are using the one notation. T1 we have to find out. M1 is 39.9. For helium, T2 is minus 20 degrees centigrade. Convert into a Kelvin. So minus 20 plus 273, therefore 253 Kelvin. So and M2 is equal to 4.0 atomic mass unit. Now we are using the equation VIMS of 1 mole gas. VIMS is equal to under root of 3 RT upon M. So for argon, we use the notation 1. VIMS 1 is equal to under root of 3 RT1 upon M1. And for helium, VIMS 2 is equal to under root of 3 RT2 upon M2. But here, the VIMS of both gases are same. Therefore, VIMS 1 is equal to VIMS 2. Substitute the value of this equation. Under root of 3 RT1 upon M1 is equal to under root of 3 RT2 upon M2. 3 are cancelled. Square root of both sides is also cancelled. Therefore, T1 upon M1 is equal to T2 upon M2. Now we have to find out the T1. T2 given, M1, M2 given. Therefore, T1 is equal to T2 into M1 upon M2. T2, 253 Kelvin. M1, 39.9, M2, 4. Therefore, we obtain 2.524 into 10⁻³ Kelvin. Therefore, 2524 Kelvin temperature. The VIMS of argon is same as the VIMS of helium kept at -20 degrees centigrade. And suppose we want to find out in also degree centigrade, therefore T1 is equal to 2524 minus 273. So that much degree centigrade. Right? Find out yourself.